Okay. Yeah. So now this is a very important sum. Becky records the population in millions in 6 cities and ranks such population within Becky's country. Her results are given. R. So this is your variable x. Always when you get confused, always your first is your variable x and this is your variable by. Use natural log to find the value of Pearson product moment correlation coefficient for log graph and semilog graph. All calculator work. So what do you do is, so parameter means A and B.
Oh, so they want us
to find a A and B regression line.
In terms of
Power.
Okay, got it.
Now see, you first take your log graph. So your list 1, you put in this 1, 2, 3, 4, 5, 6. List 2, you put in 6.5 and all these values. Your list 3, I'm doing the log. So I'll take log of list 1. This is ln log of list 2. Correct? I've taken log of list 1 and log of list 2. Then what I do is I go to linear regression. 2 variables. I put list 3 and list 4 and my linear regression. And this is your, if they ask you Carl Pearsons, you have to write this value.
Yeah.
Semilog, what will you do? What will you do in semilog? R versus LNP. R versus LNP. Remember, your Y is always LN. Huh?
Yeah, list.
So LNP you have to take. So R and LNP. So this is your R, this is your R, and your LNP is list. Which one?
1. To 1 and 4.
1 and 4. You have to take list 1 and 4. So you have to put in your list 1 and list 4. Okay. Take your regression. Set. You set it here. Actually, they should come in here first. And then you get your regression, and this is your Pearson moment. Carl Pearson R, which is. Now to check, hence suggest the linear regression, hence suggest the form of relationship. Now to suggest this relationship, you look at R square. So wherever R square is closer to 1, and or whichever case your Pearson moment is higher, either case it's the square of this one.
Yeah.
So this is higher. So I'll take this one. So this is which one? Log.
Yeah.
If it's the log, then what kind of relationship is this?
AX. AX is to
Power rule, yeah. So P is equal to A R raised to N. Use the variables that they have given. So this is your Y. Remember, this is your Y, this is your X. So P is equal to A R raised to N. P is equal to A R raised to N, I'll do.
Yeah.
Correct? And then I look at this. Your A is the slope. And here the slope is your A. So that's your slope, which is -1. Your N is -1. And your y-intercept here, that's your B, 1.8873. That's your ln A. So you solve that?
Yeah.
Put the value of A back, put the value of N back, and that's your model.
Wow.
Very important, sir. Very important, sir. Very good. The variables X and Y in the table below are thought to be modeled the power y is equal to ax raised to n. So that's your log. Now log of a negative number does not exist. Therefore the sum is important. In that case you have to take the modulus. Very important sum. So then you take modulus of this because the numbers are negative. So you make a table with your modulus x, modulus y. Correct? You take a table. You put this in list 1. You put this in list 2. Get your linear regression. Correct? This is slope. This is a y-intercept. So your slope is n. This is your n. So your n is equal to 2. Correct? 2.02. And your y-intercept is ln A.
Yeah.
Your y-intercept is ln a. So e raised to that. So y is equal to minus 4.88 x squared. Since all the y values are negative, now in the end you put a minus sign back. Don't forget this. This is the most important step. Since all the values are negative in y, your graph, your a won't be negative, but at the end you put it back.
Because you're removing the value.
Because there's a negative. Now this is very important, very important.